You remember Tandy computers, don't you?
The Tandy 1000, available at Radio Shack computer centers and so affordable. Tandy technology, service, and support are clearly superior.
Well, if you're not over 30, probably not so much. And that's because Tandy stopped making computers in 1992. This was after an entire decade of being very successful in the small, compact home computer market. The Tandy 1000 series itself spanned from 1984 right up until 1992 at the end. Before that, and even at the beginning of the Tandy 1000, they had color computers, and before that, they had TRS-80s. And not only did they make small computers for your home, they actually had business machines as well. But what we want to talk about today is the Tandy 1000 RSX. So this is the last machine in the entire Tandy 1000 lineage. It was preceded by the Tandy 1000, hold on to your horses here, the Tandy 1000A, 1000 HD, the EX, the HX, the SX, the TX, the TL, the TL2, the TL3, the SL, the SL2, the RL, RLX, and the RSX. That was all one series of PC compatible computers that started in 1984 until their demise of manufacturing in 1992. So what we're going to do here today is we're going to open this up and do a summary of what we find inside. The machine still works, has its original hard drive and the software that was on it when the owner turned it off in 1996. So first, let's dive into the hardware, and then we'll jump into the software and kind of see what the computing world looked like in the mid-90s. So first, let's talk about what's on the outside. So the front is pretty plain. We've got a nameplate and a 3.5-inch 1.44 megabyte floppy drive and a simple push-in, pop-out power adapter. The sides, we have some air vents and screws. This is one of two screws that hold on the case. And on the back, we have our ports. So very quickly, we'll go through here. Mic and headphone ports, a volume control, an RS-232 9-pin serial connector. This is a parallel port, PS2 keyboard and mouse, a 14-pin, not 15-pin, VGA connector, and we have an aftermarket sound card that's been installed a long time ago by the previous owner. So on the sound card, we have a game port or a MIDI port, speakers labeled, a volume control, and then line out and line in here as well. So let's open it up and take a peek inside. So now that the screws are out, all we have to do here is lift and slide slightly forward, and the case comes right off. One thing interesting to note here is this back panel is actually just a piece of clip-on plastic. Notice that it contains the serial number. So the model number and serial number were all on this piece of plastic. So presumably, if you needed a warranty repair back in 1992 and you wanted to change the serial number, you only need to have a backplate off of another machine to do that, and you could have faked your way into a warranty repair if for some reason your serial number was not eligible. And here is the basic guts of the machine. So we have our motherboard back here. Up here is the hard drive, floppy drive, and here's that aftermarket sound card. Let's turn it around and get a little better view of what's going on here and talk about what's in the components. So here we have an up-close view of most of the motherboard, at least the main components on the board. So let's dive in and talk about what we find here. We'll cover a little bit of history as we go along too. So here, this small square chip is the 386 processor. This chip is made by AMD. It is an SX and it runs at 25 megahertz. Now, what does the SX designation mean? It means that there was no math coprocessor built into the chip. A math coprocessor would be a specialized compute unit for processing floating point mathematics at a much more efficient and faster rate than the processor itself could do. It's not that you couldn't run software that required that computational power. It would just run slower than if you had the coprocessor. And that's what this socket was for. So you could buy an 80387 chip and place it in this socket, and a coprocessor, applications that required coprocessors could utilize that to perform faster. A little bit of history on the 386 chip. Intel canceled an agreement with AMD after their 80286 chip to share technology, essentially cutting AMD off from the code and schematics and other technologies that they would use in order to build the next generation of chip. Intel argued that the agreement was no longer valid and only covered up to the 286, and AMD argued that that agreement covered derivatives of that work, which they considered the 386 to be. AMD took Intel to court, and after 5 years, AMD prevailed. What that meant is, in the meantime, AMD was forced to reverse engineer Intel's technology for the 386 chip rather than just use the documents that Intel would have normally provided. And in the end, AMD actually provided a 386 version of the chip that was much more efficient than Intel's version and still used the same microcode, or rather it was compatible with Intel's microcode, and ultimately became more powerful in the end, as AMD was able to release a 386 version running at 40 megahertz and Intel having released it only running at 33. So moving on, this long chip here, this is a BIOS chip. This has a Phoenix BIOS in it, and this is dated May 13, 1992, and it's version 1.10. Very, very early version of a Phoenix BIOS here. So a little bit of history on that. So a BIOS was a chip that you removed. You didn't flash these chips, although this one has a cover. So this is probably a reprogrammable chip, but unlike flashing BIOS today, this chip would have to be pulled out and put in what was called an EEPROM reader in order to read and write to it. EEPROM meaning erasable. And then you had EEPROM, which was electronically erasable. So if you wanted to upgrade your BIOS in a machine like this, you actually had to pull this chip and replace it with a compatible chip that was a newer version. It was kind of crazy, but that's how it worked. Right next to that, we're going to skip over and go to the far side here. So these two particular chips here are the built-in memory that the machine would have shipped with, and that would have been 1 megabyte. So the RSX machine came with 1 megabyte of soldered on RAM. It's 70 nanosecond RAM. It's in 2 chips, which would have been equivalent to 4. Previous to this format, you would have had 8 chips, crazy as it may seem, and you would have to have an entire bank of 8 chips to fill up. As RAM advanced, they were able to condense those, and this one actually has only 2 chips soldered onto the motherboard. There are 2 SIM sockets right next to that, and we'll pull one out just so that you can see. So SIM sockets were very much like our DIMM sockets today, our DDR sockets. However, they're much smaller form factor, and they're much smaller size. So each of these chips is 4 megabyte in size, bringing the total capacity of this machine up to 9 megabytes. Please keep in mind, I'm not saying gigabytes, I'm saying megabytes. So 1 megabyte from the factory. The owner of this machine purchased 4 megabyte SIMs, 2 of them, placed them in, bringing the total RAM size up to 9 megabytes. There are a couple of chips here labeled Tandy, or TC rather, for Tandy Corporation. My guess is that they are for the built-in Tandy sound. Tandy had their own version of sound that they adopted from the PC Junior in the early 80s that was 3-voice and much more capable than standard PC sound at the time, which would have basically been some beeps and some loops in order to generate things. And Tandy sound could actually generate speech with the right programmer, so to speak, and it was much more advanced. However, on the RSX model, in order to accommodate some of the hardware, Tandy changed the address, and machines that supported Tandy sound no longer worked on this board without a modification in order to use the new address, which that would explain this side and why there's a third-party sound card installed, because most Tandy sound would not work on this machine, even though it was identical Tandy sound, just running at a different address. So let's talk a little bit about the power. We can see here the power connector comes out of the power supply and plugs into the motherboard. However, that's not the end of the line. The power then goes this way, but it's not plugged into the floppy drive. It actually travels under the floppy drive and to this connector right here, which is the hard drive. And then that same power connector travels again back to the floppy drive, and one power connector daisy chains and connects all 3 devices. Just this one connector here. And again, only 25 watts of power is all it needed to run the entire machine. Here we can see our floppy connector. This is a standard floppy connector, been in use since the beginning of time. And if you had a floppy today, it would use this type of connector. This is an IDE cable for the hard drive. So in 1992, we had moved past MFM and RLL into IDE. This is a standard parallel IDE cable. This would be what predates SATA. So we went from this to SATA for IDE drives. This machine actually supports 2 hard drives. However, only one's installed. Underneath the floppy drive, there's space to incorporate another hard drive. And actually this motherboard, well, the BIOS specifically would support, I believe, a 504 megabyte hard drive. Let's move over to the other side. So things are a little dusty here. One of the things you may have noticed is that there's no forced cooling. Even the CPU on this side is just a chip. It ran cool enough that we didn't need a fan, and there's no case fan. There's not even a power supply fan. The only ventilation was through the sides and some in the front, but no fan to push or pull air. And so the only dirt and dust that got in here was just a natural flow of air through the machine. And that's why it's not covered or caked or something you would normally find in a machine with forced air. So we have our sound card here. So let's go ahead and take that out. So we have our sound card. We'll talk a little bit more about this in a moment. So let's talk about what we find on the other half of the motherboard. So first off, we have a riser card with two slots. These are 16-bit ISA slots. Note that this is only an 8-bit card installed in there, but you could put 16-bit cards in here. And on this side, we have a couple of chips that are meaningful to us as well. So this particular chip here is the VGA chipset, and it's made by a company called Acumos. I'm guessing the model number is AVGA2. So this particular chipset was supported by a BIOS, and this BIOS is labeled version 1.10 as well, and it was manufactured on September 25th of 1990. So that places this chipset in BIOS a couple of years before the machine was actually even manufactured. So one of the problems with this chipset was that while this machine ran through 1996, and some probably used it for longer, Windows 95 did not support this chipset. So Windows 3.1 could be installed on this machine and would work. However, there was no driver for Windows 95 that was suitable enough to run the Acumos chipset. Cirrus Logic, who made graphics cards at the time, actually made a card that had a BIOS that could be flashed that would make this chipset compatible. However, you did have to install a DOS driver in order to make that happen. So you would boot DOS, you would install the driver for the chipset, then you would run Windows and your VGA would work, I presume, as standard VGA and nothing special. And really this is nothing special because these two particular chips here, 1, 2, are the built-in VGA memory of 256 kilobytes. Not megabytes, kilobytes. So 1/4 of a meg of RAM to support this. In addition to that, there was an option shown here to put in another 256 kilobytes of RAM, bringing the total up to 512K, 1/2 megabyte of RAM. And with 1/2 megabyte of RAM, you could output a VGA signal that would do a resolution of 1024 by 768 in just 16 colors. With 256K, you could get a maximum resolution of 800 by 600 with 256 colors. And you could get 640 by 400 in 256, but anything above that, you were limited to 16 colors. And if you didn't have the 512K, 800 by 600 was not even attainable. And there we have the inside. So let's talk about the hard drive. This is the original hard drive shipped with the machine. It's a Quantum ProDrive LPS model number 52S. That 52S stands for 52 megabytes. So this is a 52 megabyte hard drive. It has an access rate of less than 4 megabytes per second. It was probably a speed demon at the time it was manufactured. Again, it is an IDE drive. However, it's managed to weather all of these years and still be in operational order, even if it is quite loud. Next up is the floppy. Not much to see here. It's just a standard 1.44 megabyte floppy drive. However, this particular chip here is an SMC chip, and this is a controller for a 2.88 megabyte floppy drive. So those were not real common, but they did exist mostly in non-PC compatible machines. NEXT or Next Computers, which was a spin-off that Steve Jobs had done, actually used 2.88 megabyte floppy drives. However, most people didn't use them, and most computer companies didn't incorporate them because they were very expensive. A 2.8 megabyte floppy drive cost between $300 and $500 just for the drive. Bear in mind, this entire machine only cost $999 when it was new, so putting a $300 floppy drive in it didn't make much sense. And I don't have an exact cost on floppies. I just know that they were far more expensive than the standard 1.44 megabyte floppy drives or floppy disks. And it was only out for a couple of years before iOmega and other companies came out with 100 megabyte, what they deemed floppy drives, which were really kind of removable hard drives if you ask me, but they did have 100 megabyte drives that were far less expensive than the 2.88 drives. The last thing is this is the internal speaker, presumably hooked up to the Tandy sound that we're not going to be able to get to work, but it's a much bigger speaker than you'll find in computers today. It's an actual speaker rather than just a noise generator. And that sits in the front of the case and would play forward toward the user whenever you played your games or anything that required sound. Now let's talk about the sound card that was in here. So we know that this is an aftermarket sound card. It did not come with the machine. It was purchased at some point later by the owner of the machine, and it's quite dusty. There's not a lot of information on this sound card. I do know that KTL was the manufacturer, and the model number is KTL3180. And I can tell that there's a Yamaha sound chip on here, and there's also an Aztec sound chip on here. Now, Aztec was a company in the early 90s, and maybe even the late 80s, but mostly in the 90s. They manufactured Sound Blaster and AdLib compatible sound chips and cards. Maybe debatable on the cards, but at least sound chips. And those were used on other cards by different manufacturers in order to produce Sound Blaster compatible audio for machines. When I search for the model number and information on this, I really get two major hits. One is for the FCC with the registered ID here. And the other is a website that documents unknown audio cards. It really is pretty barren out there. So if we flip it over, there's not much to see here. Again, the FCC ID, just a couple of stickers, but nothing to indicate its identity. And apparently the KTL manufacturer is long gone out of business, not making any other hardware. Up here, there is a CD pass-through connector. So if you have a CD in your computer, you most likely don't have this connector or a need for it. But it used to be when you put a CD in your computer, which this one wouldn't even support because there was no bay for it. In order to get the audio from the CD, the digital audio, you had to connect a special cable that went from the CD into your sound card. And that would be how you got your audio. That would then work much like a line in, and the card would mix it into your sound so that you could get a sound card generated sound mixed in with digital quality audio from your CD. So if you played a game that had, lasers firing and things like that, but then also had people talking, the talking could be recorded as CD audio and passed straight through in full quality. And then the sound card could take care of making all of the blaster noises or whatever sound that were needed. So here, the volume control was very clunky. As a matter of fact, it's even stiff right now, but you turned it. And since this was on the back of the machine, you actually had to reach around and turn it with your finger. And if you had wires plugged in here, that was just going to be a pain. There was really no other way to turn it down. There was no software volume control. If you had a joystick, you could plug it in here. And this could also I'm not sure on this sound card, but this could be typically used as a MIDI port. So if you had a MIDI device for music, you could plug it in and you could record music and play it through your computer. And I believe it would output different music as well. So that's pretty good coverage of the inside of the RSX machine here. Let's put it back together. We're going to hook up a display, a keyboard, and even a mouse. And we're going to turn it on. And we're going to see what software life was like in the mid-90s. Let's talk a little bit about what we had to do to make this machine work. So first we had to track down an old mouse. Look how long this cable is. This is about a 10-foot cable. We needed a PS2 port. This is an old HP. It's a ball mouse. If you don't know what a ball mouse is, it's quite frankly a ball. Big heavy metal ball covered in rubber. And inside here are a couple of rollers, and the ball moves around freely in there. This ring holding it in. So you always had to take these apart, clean out all the dirt periodically when your mouse stopped working. We had to get our mouse. The next thing we had to track down was our keyboard. This is an old IBM keyboard. Unfortunately, it's not as good as the really old IBM keyboards, which were mechanical. It is a 101 keyboard, is what they called AT compatible. And look at, again, this cord. This cord is crazy. It's about 8 feet long, and that's without stretching out the phone cord portion of this thing. It's really nuts. So let's move that to the side. Talk about the next thing. So it does have a VGA connector, but it is a 14-port connector. So we had to dig out our VGA cable. However, these are 15-pin. So if you can see inside there, 15 pins that plug in. However, on the Tandy VGA adapter, pin number 9 is not in use. Therefore, they left it off. Now, pin number 9 is not in use even on this cable, but it's there. On the Tandy computer, they removed the hole that this would fit into, preventing this from connecting. Let me show you what I mean. So see here, right in the middle of those pins, there's a solid portion. That's where they didn't put the hole in. There's no reason to not put it there, but they didn't. So what this means is that the other end of our cable, we had to make a modification. So we bent pin number 9 over. Turns out that pin number 10 is ground. So we bent it over and pushed it up next to pin number 10. So if it touches anything, it just touches ground. So this next part, we were going to show you how to boot this machine up pretty easy and go into some software. However, we ran into some technical difficulties. Through a couple of power cycles, we actually ended up in a failure here. I'm not sure if it's the hard drive or it's the power supply. The drive does spin up and it seems to attempt to boot. And if we put a floppy in that's formatted with DOS, we can boot to DOS from that. But when the drive tries to initialize, you can hear kind of a power loss in the spinning where it just rolls down a little bit. It causes the drive to reinitialize like you just turned it on. You check the BIOS. All the settings are good there, but if there's something in the power supply and the drive is requiring a little bit of power and the power supply is not delivering that, it's kicking that drive offline when it's trying to check, and it just never comes back. We tried a couple of things with the drive. These older drives, you could tap on them if there was like a head freeze or something like that. It just didn't seem to come back. So there was a few boots through there, and actually at one point, there was additional errors, so the RAM itself would actually fail the second check at about 4.5 megabytes. And that wasn't too bad of a problem. It would just limit the maximum RAM to 4 megabyte when that occurred. However, that went away, but the hard drive failure continued. Even though we were able to get the drive to boot one time after the first failure, it's just not doing it anymore. So we're going to piece together some of our footage that we already got, and we're going to talk about some of the software that we find on this old machine. So the first thing we're going to explore is DeskMate. DeskMate came with just about every Tandy computer and was a GUI application that tried to be a form of Windows before Windows came into its own. You can see that we have a graphical kind of presentation here of what's on our computer. Some text files, there's some applications. It's a game actually called Cubes, and there's other things, programs, address cards, checklists, and things like that. And then there's a menuing system across the top. It did have mouse support, however, it works really poorly on here, and it was really easy to use by keyboard. As you can see that all of the menus at the top are assigned to function keys. So just looking at some of the stuff, we can see that we could check on some basic system diagnostics. We could do some basic disk information. We could actually even format a floppy disk, but the actual DeskMate itself didn't do the formatting. The formatting actually occurred from a shell out to the DOS format command. So if we fill in the actual information of what drive we want to format, and we give it a volume label or not, and we can attempt to format a floppy disk. Now our floppy disk here is empty, so it will actually format, but we're going to fast forward through the format process, as it's actually quite slow to format a floppy disk. Keeping in mind that floppies are 1.44 megabytes, and it takes quite some time to do that. So here, even at 500% speed, we're going to see that formatting a single 1.44 megabyte floppy drive takes well in excess of 1 minute. And you had to do this on every single brand new floppy you put into your machine. It was pretty time consuming for quite a little bit of space. So we're not going to format another drive. We're going to hop back into DeskMate and we're going to explore a little bit more. So similar to Windows 3.1, DeskMate supported creating these little windows and boxes on the screen where you could populate those with programs or files. And we're just going to explore putting one on the screen here real quick to help us organize. And we're going to specifically do the draw files that are on this machine. So we can put it where we like. We can move it around. We're just going to put it on the left. And we can see a couple of files in here we can open. So we're going to show a little bit of this graphic prowess here. We're going to ignore the error because we're not really sure what that's asking for. But the graphic prowess on this machine is very low. And just loading this simple, what we would call a Microsoft Draw type file is It's very time consuming and obviously very slow. I mean, it clearly saved things in vectors with fill patterns, and it's recreating it very similar to the way it was drawn by whoever actually did this. But that is incredibly slow. And it's because there is no graphics acceleration, and DeskMate isn't designed for graphics. It's just kind of a desktop utility application. So we can really see that 1992 to 1996, this family was struggling with doing anything really creative using DeskMate. And that is really the reason why you don't really find anything on that DeskMate desktop, because they just weren't using it. Okay, so that's enough DeskMate. So let's go ahead and exit out of here. The next thing that we want to really talk about that we find on this machine is ProWriter. So ProWriter was a word processing program that is DOS based. I think it's from 90 or 91, but it is going to be a very basic program. So we can see here the professional write main menu, copyright 1990, and we're just going to create a simple file here and see what we can do with it. So first, let's just type a couple of lines in here with my spectacular typing capability. And then we're going to jump over and look at printing. Now, we're not actually going to print, but I want you to see how bad the printing system is in an application like this. So the first thing we'll do is we're going to do the preview working copy. When you see this, it really was this bad, even on my actual screen, not looking at this terrible captured video. It was unreadable. That's just my couple of lines of text. And it's very black and white. That's very pixelated text there. It's not visible at all. So we actually kind of have to play around here and try and figure out how we can actually see it on. So I was able to find an option and actually see what I was going to type. So this is very much how it would have looked like printed out on a dot matrix printer. It would have been in a basic font, nothing special, and that would have been our printing. We were going to show a couple of other things like loading and saving files, but we had a problem with floppy drive on top of our other problems, so that footage is actually just going to hit the cutting room floor, and we're going to move on to what you really want to see, which is games. First up is going to be Wolfenstein 3D. We do have sound. So after we get past this screen, you'll get this marvelous sound that is capable of the Sound Blaster. So this is more like MIDI sound or Sound Blaster sound. It's actually pre-programmed sound. It's not recorded sound, and it's not sampled. There is some sound sampling with doors opening, gunshots. Actually, the gunshots may not be sampled. They might actually be MIDI. And the Nazis in this game actually talk, even though they're very hard to understand. And their talking is sampled. You'll hear them say stop a lot. They like every Nazi says stop. Get some extra bullets. So this is food. Food is health. I guess it's a big turkey leg and some green beans. So there is no up and down axis. There is only left and right. You can strafe by holding down the Alt key. Control is shoot, and space is the action button for opening doors. You keep hearing them yell stop. If you run out of bullets, you switch to a knife automatically, and you automatically switch back to a gun once you pick up bullets. So I'm just going to pick them up just to make sure we don't end up in melee mode. Those are treasures. There's a percentage that you get at the end of each round to tell you how much treasure you actually picked up. Other than that, it's just a score-based mechanic. There's some more treasure over here. Those fantastic sound effects. And I'm just running directly toward the end of the level. I'm not trying to clear. I might have played this once or twice back in my early days of computers. So here we are at the end of the level. We open the door, we pull this, and we'll get our status screen. We actually killed 63% of the people, 34% of the treasure, and about over a minute and a half. So Wolfenstein's not known for variety, not in Wolfenstein 3D, this original. You'll see this next level is not much different from the previous level. This game is actually playing in a resolution of about, I'm not sure if it's 320 by 200. It's a little bit higher now. I'm going to guess it's 640 by 400, and it's in 256 colors for sure. There's too many different blues there to not be. So it's pretty basic, but let's go ahead and get out of here and move on to our second game. So it's gonna usually this prompt makes fun of you, but it is dynamic. So now we're at an intersection. A sign says press yes to quit. Sometimes it asks you if you're going to be a pansy and quit. Something along those effects. So Commander Keen was another game that was very popular at the time. Keen 1 and 4 is on here. We'll play very briefly of each because they're actually pretty difficult to play and they're really annoying sounds, which you'll hear. So it's a side-scrolling, isometric, top-down combination, 16-color game. And it was really popular. But I found it fun when I played it when it was new. So that sound that you're actually hearing there is not the sound card, is not the generated sound from the Sound Blaster. This is actually internal PC speaker sound, and that's why it's so annoying. So the control scheme is terrible. Control is jump, but you have to, once you get bullets, fire is actually control, and you can see the gun come out there. I could jump over this guy. Fire is control and alt together. Spacebar brings up the menu, and there's not a lot of other controls here except left or right. So the guns are down there, so if I want to get bullets, I'm going to have to go down there and collect that. So then we have a couple of bullets, we'll take a couple of shots, and then we'll move on. I feel there's a little bit of a Super Mario feel to this game. Guess we're done with that checkpoint. And there's Commander Keen 1. We're going to quit this and we'll go on to Commander Keen 4. We're only going to go directly to 4 because the others are not in between there. So I want you to take notice here as I do this. This entire game is less than 1 megabyte. It's 802 kilobytes. Would fit all on this. The entire game would fit on this floppy drive, and would run from the floppy if you didn't even have a hard drive, and you could play the entire game. We can definitely see there's more color. Let's just do an easy game. Keen enters the Shadowlands. So much improved sound. The graphics I wouldn't call much improved. The control scheme is definitely better. Oh yeah, I forgot you get a pogo stick in this one. I'm not sure why a pogo stick, but I think you can land on these. Nope. So I'm jumping higher by hitting the control key. That was pretty basic to get through that checkpoint. So let's try one more level and then we'll wrap this up. Not much different from the last. Trees look like they're high. Ooh, bugs in there. Oh, don't hit him. All right. And that's it. Go ahead and get out of here. Back to the... Oh, okay, I have to do it before I get here. I'm not sure what Paddle War is. Oh, I actually remember this. I do definitely remember Paddle War. Not sure why it was in there. 2 games in 1, right? I score. All right, let's get out of here. So just for fun, we're going to run the golf game that's on this hard drive. This is going to be a very painful experience simply because the game is so bad. It's only 356 kilobytes in size. And it's not even that the game is bad. It's just that this game comes from a time when computers were worse than this. And this computer doesn't handle it very well. And to make this worse, we're going to copy the golf game to a floppy drive and run it from the floppy drive. Why? Because we can, and you'll just see how slow it is. Notice how the other games actually loaded relatively quickly when we were running from the hard drive. Running from the floppy drive is going to be a whole different experience. My very first PC-compatible computer was a Tandy 1000EX, an all-in-one with a 360 kilobyte floppy drive. This game would have barely fit, and certainly I couldn't have saved any save games with 356K reserved just for the game. But it definitely is going to hurt our eyes when we bring this up. So let's go ahead and launch the game and see what happens. So right off the bat, load times are horrendous. We get a couple of selections for displays here. None of them work well on this machine. The title looks good, but watch when we get to the splash screen. This is going to be it's almost unreadable even when you're sitting in front of it. You can see a little golfer comes out of the grass there. Maybe that's a little throwback to Caddyshack. But this game, it just I'm not sure where it came from. You can see it's copyright 1986. And it's from Accolades, which was a big company for games back in those days. But it didn't work very well, and you can see that we got kicked out to DOS. And one of the side effects was that since we got kicked out, look at our font. It's completely changed it, and it's terrible. So now we're going to try and run it again from the hard drive. You can see it loads much, much faster, but we're back to exactly where we were. So that's enough of that, and we're going to skip on now. So there you have the Tandy 1000 RSX, the last in a long series of Tandy 1000 computers were designed for the home, certainly not for business, that would keep your kids entertained, let you do some word processing, and maybe even get on the internet. If you like this video, please like and subscribe and leave your comments, good or bad, below. We like them all. Thanks for watching.